All right, today's lesson is going to be on 5.3, proving triangles congruent. And this is the first lesson where we learn some of the shortcuts instead of having to prove all the parts. And I'll hopefully explain that here when we get to the first one. So the first theorem is this SSS theorem. And so I would call it the SSS congruence theorem. And so that's going to be our first shortcut. So we really need to understand the different shortcuts we're going to have. So before today, we had to prove 6 things. 3 sides, 3 angles, 6 things to prove a triangle is congruent. And what this theorem is saying is that if you have the 3 sides of one triangle congruent to the 3 sides of another triangle, then that's good enough. You know the triangles are congruent. Right? And the activity I kind of skipped over that we do in class kind of proves this. And you can grab some popsicle sticks at home or something and prove it to yourself. But it is a theorem, it is a rule here that we're going to use. So the side congruence theorem. And so let's look at example 1. So this is going to be all proofs today. And so example 1 has the given. I've already rewritten it down here. So that'd be first step. It would be good to put some of these proofs in your notes so you have them for quizzes. All right. Segment GH is congruent to segment KJ. And so when I say things are congruent, I should mark them in my picture. So GH is congruent to KJ. And then segment HL is congruent to segment JL. So HL is congruent to JL. And then lastly, here it says L is the midpoint of GK, of segment GK. So what does that mean? Right. Well, if L is the midpoint, that means it splits the bottom here into 2 equal parts or 2 equal halves. And so that's what I need to name. So GL is congruent to, and it doesn't matter to me if you say LK or KL. And we knew that because we knew what the word midpoint meant. Definition of midpoint. If you put definition on bisects, because you know midpoint means bisects, that would be okay for me as well. All right. Now, do I have enough information to say this, to say what I'm trying to prove? All I know right now is the 3 sides, but do all 3 sides match? Yes. And so I can say triangle GHL is congruent to triangle KJL by side congruence. Let's look at another one. Again, proof. Again, start with the given. What is the given here? Segment RQ is congruent to segment RT. S is the midpoint of segment QT. First, let's mark what they told us is congruent. RQ is congruent to RT. So they already told us that. Remember, the next 2 questions I want to ask myself are, what is the given? How does the given help me? What is the given telling me? And is there anything I'm expected just to see? And so the given tells me S is the midpoint. Midpoint means it bisects or splits it into 2 equal parts. And so QS and ST must be equal. So let's mark that. And then let's say it down here. So segment QS is congruent to segment ST or TS by definition of midpoint. Now, I don't have all 3 sides yet, so is there something I'm supposed to just see? My geometry brain is supposed to just be smart enough to know. When I look at the triangle on the left and the triangle on the right, this segment RS is in both triangles. And so does it change size? Nope. It's in both triangles staying the same size. And so RS is equal to itself. And so segment RS is congruent to segment RS. And that's called the reflexive property. Now I have all three sides. So now I can say triangle QRS is congruent to triangle TRS by side, side, side congruence. So these proofs are shorter now that we have these shortcuts. Let's look at the next shortcut. Side, angle, side. So really focus over here. Side, angle, side. So you have two S's and an A. So two sides and an angle. Now, the order matters. So side, angle, side. The A has to be in between the S's. So side, angle, side. Also, I can never skip two things in a row. So if I go around this way, first it would be side, side, angle, but I would go side, skip an angle, skip a side, skip an angle, side. I can never skip two in a row. All right, so side, angle, side, or it doesn't matter which way. All right, so this side matches with this side, the angle in between them, and then the sides here. So that's called the angle between them. They use the word included. So two sides in the included angle of a triangle are congruent to two sides in the included angle of a second triangle, then the triangles are congruent. Right? Let's mark it up and demonstrate it here. So if I have this side congruent to this side, and this side congruent to this side, then what angle do I have to have? Right? Do I have three angles to choose from? But because of the sides that picked, I have to have this angle is congruent to this angle. I have to have the angle that would be in between the sides that are congruent. And so it's side, angle, side, congruence. Right. Again, proofs. Again, step one is the given. X is the midpoint of segment BD. X is the midpoint of segment AC. That was all given. So I just rewrote the given in my first step. Again, there's two parts of a proof. One, or two first initial parts of a proof. One is, what is the given telling me? Two is, what am I just expected to just see? Well, before I go too far here, I want to make sure we know what triangles we're talking about. So DXC is this one, and BXA is this one. So those are the two triangles that we're talking about. So when they say X is the midpoint, what does that mean? Well, it means it splits BD into two equal parts. And so I know that BD has two equal parts. So these equal parts. So I'm going to say that first here. Segment BX is congruent to segment DX, because that's what midpoint means. And I'm wanting to erase that and write that better, but that is the right thing here. So what the heck just happened? So BX segment is congruent to DX segment. Definition of midpoint. Now, midpoint also was a part of AC. So for AC, I have two equal parts. And so I have AX and CX. And so I can say that here as well. AX is congruent to CX because they're both definition of midpoint. So I could make that steps 2 and 3, or I could just make it all step 2. The angle in between them. The angle in between them would be this angle and this angle. So how do I know those two angles are congruent? Those angles would be angle DXC is congruent to angle BXA. And if you said they were vertical angles, then you are on the path of success. And so now I have enough to say triangle DXC is congruent to triangle BXA because side, angle, side, congruence. Next, we have this picture. Now, this picture is a little bit hard to see, so I'm going to redraw the triangles here. The triangles are right here. And so I want to redraw them out here just because it's a little bit hard to see. All right, so you have K, J, L, and M. Right. And to start out, they tell you segment KL is congruent to segment LM. And they tell you that angle JLK is congruent to angle JLM. So we have one side and one angle already congruent. What else can I know? The given doesn't have any midpoint word, bisect word, parallel words. So there's nothing with the given. The given's not helping me anything besides just straight up what we already marked. So what am I supposed to just see? What is my smart geometry brain supposed to just know? This line is in both the top and bottom triangle. So JL is congruent to itself. And so JL is congruent to JL. That is reflexive property. Mark that as well. That line's equal to itself. And so now I can say the top triangle is congruent to the bottom triangle, which they call triangle JLK is congruent to triangle JLM by side, angle, side congruence. Now, these ones aren't proofs. They're just asking you to know the rules and whether they apply or not. And so for this first one here, they have just two sides. Is there any rule with just two parts? No. But you got to be able to know things. You got to be able to see and just know vertical angles. And you got to be able to see and just know reflexive property. And so this one is yes, because of side, side, side congruence. How about over here? Two sides and one angle. And is the angle in between the sides? Yes, it is. And so this one is yes, side, angle, side congruence. Down here, two sides, and an angle. All right. But is the angle the one in between the sides? No, I would need this angle down here. And so you really can say at this point, not enough info, right? Because it could still be there congruent. We just can't prove that yet. Right. This is the assignment in my class. I hope and wish you all the very best. Let me know if you have issues.